Hello, welcome to you all. Nice to see so many people joining today. I will start off with a little practical information and continue to introduce the organization and the Waste for Warmth project before I hand over the word to the Engineers Without Borders volunteer engineer, David Osborne, who is the main speaker of today's event. So to get the best bandwidth possible for all of you, I would like to remind everyone to turn off their video and to mute their microphones. I'd also like to inform you that the webinar will be recorded and that the recording will be shared online on our webpage. So by participating in this meeting, you also prove our recording of the event. We will open for questions at the end of the webinar, but if you have any questions along the way, please feel free to write them in the meeting chat, and we will do our best to reply at the end of the talk. So, my name is Egil. I started as project manager with Engineers Without Borders in January of this year. I'm working almost exclusively on the Waste for Warmth project, which is the topic of today's webinar. So briefly summarized, Engineers Without Borders were 4 people working in the administration here in Oslo, and we also have a board of directors and 9 local chapters with a total of 800 members. Engineers Without Borders' goal is to make technical expertise available in fragile areas around the world. We believe that knowledge and technology are important factors in achieving the UN development goals to eradicate poverty, fight inequality, and reduce climate change. So we work together with organizations in the field wherever there is a technical need. Next year is the organization's 10th anniversary in Norway, so feel free to follow us on social media and through our newsletter to keep informed on what we do. Now, Waste from Warmth is a project developing local manufacturing capacities for tent insulation for displaced people in cold environments. Millions of people are living in temporary shelters across the Middle East, and among the challenges they face is a lack of protection against the cold. Some of the existing shelter heating solutions are costly and energy intensive, and the current approaches to assistance rely heavily on distribution of blankets, stoves, and fuel. So this project started when Engineers Without Borders Norway teamed up with 3 other organizations applying for funds from Innovation Norway's Humanitarian Innovation Program. So EWB leads the project, contributing with volunteer and partner resources. And the other organizations in this consortium are International Federation of Red Cross's Shelter Research Unit, who develop tents and sheltering solutions. There's also Field Ready, an NGO working to strengthen local responses and manufacturing in humanitarian crisis. And lastly, there is a small French startup called the Polyfloss Factory, who are the technology partner on this project. So over the last 8 years, Polyfloss Factory has developed a way to turn waste plastics into a candy floss-like material with simple field-friendly machines. And this polyfloss material has been measured to perform particularly well as an insulator. So between these 3 NGOs and the company, the Polyfloss Factory, our challenge is to further develop their machines and also to make a safe-to-use plastics-based insulation product that can be integrated with existing tents and structures, and to set up a sustainable local production of this, creating work opportunities for displaced people in the field, and also tackling a local waste problem. So we work to make this happen on a range of fronts, and one of the challenges we faced in developing an insulation product is getting our heads around all the various standards and safety measures we need to comply with when introducing this product into someone's living space. And that's even just for testing. So here's David. David is a volunteer on the Waste for Warmth project. And to deal with project requirements from early on in this project, he spent time mapping the relevant standards and setting targets for product performance and technical requirements, just on a range of different variables. So he's been instrumental in providing our product development with clear targets. David will give you a lot more detail on how he's worked with this, but he's also a returning Engineers Without Borders volunteer, and he will also tell you a little bit about some of the previous assignments he's been involved in. And with that, I'll just hand over the word to David Osborne.
Thank you, Egil. Good morning, everyone. My name is David Osborne, and my day-to-day job is as a materials engineer in the oil and gas industry in Bergen. I've been a member of Engineers Without Borders for a couple of years now. In the course of these 2 years, I've been involved in 3 projects, including this one, Waste for Warmth. So all 3 projects have been focused on materials processing, mainly recycling of plastics. And as part of this intro, I'll quickly mention the 2 other projects before I go into Waste for Warmth. Here is the location of my first assignment in the Algerian Sahara. We spent 10 days visiting refugee camps that had a failing waste management system. Especially visible and problematic was plastic pollution. The UN Refugee Agency, who were supporting these camps, needed technical help from us to find a solution to the waste problem there. So here you can get a sense of the situation around the camps. The support from Engineers Without Borders resulted in a solution to recycle plastic locally, according to established machine designs and a sustainable business model. This would then relieve the burden on the currently overstretched waste collection and disposal system. The second project I'm actually currently involved with is a project sponsored by the Norwegian Technical Union, NITO, and was conceived by NITO students. The aim here, based in Tanzania, the aim here is to install machinery and help set up a sustainable business to clean up a stretch of beach just north of Dar es Salaam. Engineers Without Borders, together with a group of students from NITO, will be providing hands-on support on the beach site to set up this business. And now we go on to Waste for Warmth, the main part of this. So when I started the Waste for Warmth project, we understood that polyfloss was a very promising material with respect to thermal insulation. However, what we were not sure about was the range of other properties and functions that had to be fulfilled to make sure that this was a safe, strong, and durable material for using it in emergency shelters. The first phase of the work was therefore to list out what properties we needed to design for, and also the methods that should be used to test and verify said properties are acceptable. So in the beginning, we identified the obvious ones, so fire resistance, strength, and weight. But as we looked further and further into this, we discovered quite a number more. To add to the complexity, we had to consider various concepts that we had on the table. So how polyfloss would be applied to the tents. So we had one concept, which was stuffing in the sleeping bag, or else as panels on the tent walls, as floor tiles, and also as a complete tent liner. So each of these concepts would then need its own set of standards. For example, moisture permeability in the sleeping bag is a desirable feature, so you don't get water build up in the sleeping bag. But when it comes to floor tiles, you want to have water impermeability to make sure that you don't get the floor mat soaked with water and lose its thermal resistance. So a big challenge for us is that there exists no one standard for a relief tent. It's up to the relief agencies themselves to list their own set of required properties. And to verify these properties, they refer to standards and test norms detailed in international standards, such as the one on the right here. These standards are typically adopted from the building industry and from textile industries, and also from the recreational tent industry. So the relief agencies themselves detail their own emergency shelter properties specifications in the standards in their product catalogues. So these catalogues were the main source of information for us when making the list of specifications for the Polyfloss product. Another challenge for us was that there are no current products exactly comparable to Polyfloss. So we had to then combine specifications. So for example, we would combine the specification for standard relief blankets with tent liner specifications. So let's look at an example of one property, fire retardancy. This is an extract from the Red Cross's specification for the relatively new geodesic family of relief tent. The geodesic tent specification also lists other required properties, but this property, fire retardancy, is probably one of the more critical. So here you see the property, flame retardant, and then it's given an international test standard that it has to be tested against to qualify the property, EN 13823. Then you have minimum acceptable results from the testing. Tests like these are normally performed on a cut sample of the product or the liner. And here is a photo of the test mentioned in the previous slide. It's not Polyfloss we're burning, it's just an example photo. Everything about this test, from the equipment to the evaluation method, is detailed in the international standard. It means that results are directly comparable. This test not only measures the rate of which a flame spreads through the material, but also how much smoke is emitted, and also how much flaming droplets are produced over a set time. These burning characteristics are important to measure and evaluate the fire safety. Here we had another challenge. It was mentioned before that we had to look at a number of different test specifications from different products and agencies. Sometimes, for certain properties, there was a mismatch between them. I think this really highlights the need for an internationally agreed relief tent standard. Here, the property of fire retardancy is tested according to 5 different standards and methods, depending on the product or the agency involved. There is a difference in the conservatism in these tests, meaning that some shelter tents will have a better proven fire resistance than others. So here is another test setup to measure another important property, thermal resistance. It's based on an international standard, actually from the safety clothing industry. It's a property that's key to development of the design, and we're going to develop this kind of test setup in the Polyfloss workshops. This will then enable us to correlate thermal resistance with other product parameters such as fiber thickness, density, plastic type, and so forth. So as we compiled the list of important properties, we realized that we had to separate these out according to 4 basic levels. The first level is the standards for the raw material. So for example, the property purity, the plastic type, and also that the raw material is ethically procured. The next level down is the kind of material testing on the polyfloss itself. So here you're interested in measuring thermal properties, strength, thickness. These are characteristics that are imparted by the machine and production methods. The next level down is where you investigate the final form of polyfloss, basically the wrapped and stitched polyfloss. So here you're starting to do some serious lab testing. So things like fire resistance, its strength, resistance to rot, resistance to UV degradation, and so on. The fourth and final level is the test standards to apply to the tent itself. So these tests are to understand things like the package weight, setup time, fire escape time, wind resistance, thermal performance, and ventilation. So even if the polyfloss is applied with an already approved tent, it must be shown the properties of that tent are not diminished by the application of the polyfloss insulation. So regarding the desired properties of a shelter tent, we referred to earlier field testing that had been performed by the Red Cross on prototype winter tents in Mongolia in 2015. So here we can see how some properties are more desirable than others. So for example, the heat resistant properties or heat retaining properties of the tent are 2.5 times more important than setup time and 5 times more important than unit price. So for example, if adding an extra 10 millimeters of insulation increases price, but also increases thermal performance, it may well be an acceptable trade-off. So in the end of the first phase, we had compiled well over 100 individual properties that needed to be considered for a well-functioning relief tent. In phase 2 of the project, where we currently are today, we are working with the Red Cross to narrow down and prioritize this overly large list. Our aim now is to have a simple specification for wall panels, for floor mats, for sleeping bag filler, and for any other product form of polyfloss. So to make it simple, the specification will be structured according to 4 basic categories. The first category lists the product specifications and ensures basic HSE requirements. So things like color, the size, the weight, and that it's clean and safe to use for humans. The second is detailing all the lab tests that need to be performed to ensure acceptable quality. This would include the tests like fire resistance, strength and durability. The third category is basic design requirements. So things like making sure that all the seams are not horizontal, that there are a sufficient number of windows and ventilation openings. The final category covers the behavior of the complete tent in the field. For example, how long does it take to set up? How long does it take to dismantle? How does it cope with wind, snow, and of course, how warm it stays in very cold climates. So here is an example of a table that we are currently developing for the previously mentioned second phase lab testing. This is our main focus at the moment, and we have listed the properties, the test standards, and the minimum acceptance values for polyfloss. So over the coming weeks, we'll be making a priority list of these properties for each of the product forms so that we can start to test and basically further develop the design. Thank you. Egil?
Thank you very much, David, for that walkthrough of your work, and thank you for spending time to really ensure that we understand the demands and the technical requirements of what we're doing in this project. So before we move to questions, I just wanted to briefly say, well, talk a little bit about what we're up to this autumn. As David mentioned, we are focusing a lot now on product development, on making prototypes, and also testing these prototypes and the various qualities. David's also involved directly now with product development and will join a workshop that we're hoping will take place in Paris in October, where all the partner organizations will work with Polyfloss to make product prototypes and then also agreeing on how to test these going forward. But one of the tests we know we need to do and is the full-scale performance testing of products in tents. And this is planned to take place in and around Oslo this autumn. So we're currently advertising for volunteers with backgrounds in building physics, product development, quality control and management, or other relevant backgrounds who might help us set up these test protocols, help oversee tests, and compile reports together with our partner, the International Federations of Red Cross Shelter Research Units. So if that description in any way fits you or anyone you know, please get in touch and ask us any questions or apply directly on our website. The deadline is the 20th of September, this Sunday. So with that, I'd like to open for any questions to David on this talk and to ourselves. So is there anything in the chat or anyone that would like to ask a question? So I've got a question here from Gard. She's referring to ISO 6942. I think this is a question for you, David. It's okay. On testing. As testing is done in-house, are there any requirements for third-party verification? And is lack of accreditation an issue?
So it depends on the test. There will be some degree of third-party involvement. For example, we need to have the test set up, calibrated, and certified by a third party. The final product will be tested by the agency themselves. In our case, the Red Cross. So that's out of our hands, but there will be some level of third-party control in every test.
So yeah, hello.
Hi there.
Just if I can just quickly follow up on that. So the tests as you're performing with the setup that you have yourselves, that's sort of just for benchmarking progress with the kind of results you'd like it to produce, like to see if the properties are coming along.
Yeah, so you can imagine, so there's two levels to testing. There's one for basically product development. So that's the stuff that we will be testing ourselves on in the workshop. When it comes to kind of the more critical tests like the fire safety testing, thermal performance, these will be outsourced to a lab that has been kind of basically a certified lab with all the correct kind of certifications. And we may be well, Red Cross may request to have a witness on that as well to add to that level of security and confidence. But we, so for example, with the thermal testing, we're going to set up our own jig, our own rig in the workshop. It will be, so we're going to do, what we'll do is we'll send a sample, some samples away to a lab for testing. And then in parallel, we will test from the same batch thermal properties using our own rig. And that will then going to give us, we can then correlate the two. So we'll have the kind of the verified values from the lab versus our own test results that we can work from. I mean, that will give us the stuff that we can do ourselves will be kind of have good indication on the properties, and will be good enough for product development. But at the end of the day, the stuff that we'll be publishing in the kind of catalog will come from actual lab testing, like certified lab testing.
Yeah. Thanks.
Great, thank you for that question. I see you actually have another question, Gard, in the chat. You're asking how far along are we with manufacturing prototypes for full-scale testing? This is a process we're really in the midst of right now. There has been a sleeping bag produced using polyfloss just the past week in Paris. And so basically, the very basic kind of concepts we've kind of tried to mock up, but it's definitely something we'd like to see happen over the coming months, so that we have full-scale prototypes to test in tents.
Perfect. So most of the manufacturing is done by Polyfloss in Paris, right?
It has been for the time. We've also set up workshops here in Oslo to progress on that. But for the time being, it's been easiest for us to let Polyfloss in Paris make prototypes, as they're close to the machine that's also in kind of constant development. So that's been a focus area for this first phase we've been in from January until now, is that Polyfloss has worked very intensively to make that machine go a lot quicker and to produce a more stable result.
Okay, perfect. Thank you.
Thanks. Anyone else have a question to either of us? So I've called Hanna.
Yeah.
Sorry. Yeah. I've caught a question from Hanna Mathisen. How could you say something about the circular economy aspect of this project? So this is waste management and employment. So the circular economy aspect is definitely, I mean, the raw material that we'd like to put to use in making these insulation products is waste plastics. So it will have to integrate with a waste plastics value chain locally where the production is set up. And we're also looking to design products that can be disassembled. And for the material, the polyfloss itself, to either be reused directly in another product in its current form, but it can also be remelted and remolded to other things. And this is definitely part of the setup of the project. So for the time being, we've not been able to go to the field where we would have wanted to be to kind of develop this more in proximity to the actual users of the product. So we were looking to go to Turkey and work with Turkish Red Crescent the month of March and April. However, because of the coronavirus situation, we're a little bit further away from the actual users than we would have wanted to be at this stage in time. Sorry, David, did you have anything you wanted to add to that?
So just perhaps add to the question from Hannah, that it's it's actually a set requirement to this kind of circular economy to integrate, to kind of have ethical procurement, and also to have a safe sort of management of waste. So that's quite early on, kind of bake that into the requirements that we're going to have to kind of fulfill. It's basically straight out of the UN handbook for tents. So it's a very, very important issue. It's a good question, Anna.
Does anyone else have a question they'd like to ask David or to myself? Then, if no one has any further questions, I think we actually hit time exactly. It's now noon, so I'd like to thank you, David, for doing this talk with us today, and to everyone else for participating with questions. To Vibeke for setting up today's event, making sure you all came, and to Marianne for helping us make a tight program and to keep time today. I'd like to ask you all to reach out directly if you have any comments or further questions or any ideas regarding the project that you would like to share with us. And also to remember that application deadline if you have anyone in mind for our assignments upcoming this autumn. And with that, I'll wish you all a good day.